Hey guys, it's Mr. Krieger. This is Algebra 2. This is part of Lesson 2. It's the back part of Lesson 2. And we're going to be doing some factoring here. Just practice factoring. Basic factoring. The type of factoring you learned in Algebra 1 for the most part. And we just want to make sure you're good with it because comes up throughout the entire course. Now, if we take a look at this problem, and these are greatest common factor problems, you have to find the greatest common factor of 3x squared and 9x. So a 3 goes into 3 and 9, so that's going to be part of your greatest common factor. And then with the x parts, you actually always take the x that has the smaller exponent. So in this case, actually, x is the greatest common factor, not x squared. The reason is x goes into x squared, x times, but, make sure you can see this, but x squared does not go into x evenly, so therefore it's always the exponent, the variable with the smaller exponent, that's going to be the variable that you take, the variable with the smaller exponent. Now, what you need to do to find the other factor, there were two terms in the original binomial in this case. You need to divide each of those terms by the greatest common factor. So 3x squared divided by 3x is x. And you're going to do 9x divided by 3x, and that's going to give you 3. 9x divided by 3x, the x's will divide out. 9 divided by 3 is 3. And this is the result of doing greatest common factoring. All right, very important that you be able to do this. It comes up all of the time. So I'll just go through a few more of these. Okay, next one, 20a minus 4a squared. The greatest common factor is going to be 4a. Dividing it out, 20a divided by 4a is 5, and 4a squared divided by 4a is a. Now in this last problem, we actually have 3 terms, and we see that there is a numerical value for each term, 16, 24, and 8. 8 happens to go into all those 3 numbers, so 8 is going to be your greatest common factor. Then if we take a look at the a's, you have an a squared, an a, and an a. Take the one with the smaller exponent, a. You have b's in all of them, with b having the smallest exponent. Now dividing it out, 16 divided by 8 is 2. A squared divided by a is a. B divided by b cancels out, so it divides out. Minus 24 divided by 8 is 3. A divided by a, it divides out. B squared divided by b is b. Plus 8ab divided by 8ab. It goes in perfectly one time, just 1. A divided by a is 1, and b divided by b is 1, so you just get 1. So you have 8ab is the greatest common factor, and parentheses are going to be 3 terms in the answer, just like there were 3 terms in the original problem. So you're going to have 3 terms here, 2a minus 3b plus 1. Okay, let's take a look at the next kind of problem. We have dots problems, difference of 2 perfect squares. So these are the problems where it's technically you have 2 sets of parentheses, and the square root of a squared is a, that's going to go here and here. The square root of 9 is 3, that's going to go here and here. It's plus 3 minus 3, and that's how you factor the difference of 2 perfect squares. It really works like this. It's a squared plus 0a minus 9, and if you remember that the numbers that you need have to multiply to negative 9 and add up to 0. 2 numbers that multiply to negative 9 are positive 3 and negative 3. Plus 3 and minus 3 add up to 0, so that's how you got a plus 3, a minus 3. Okay, let's take a look at the next one. Here, again, another difference of 2 perfect squares. 4m squared, that whole thing's a perfect squared. 2m is the square root of 4m squared. And 5n is the square root of 5n squared. So 5n, 1 plus 1 minus. I have to squeeze it in there. 1 plus 1 minus, okay? Finally, this one's pretty easy. You got 49 minus x squared. Just be careful here. You can't do x plus 7, x minus 7. The 49 came first, so you're going to have to do the 7 first in the parentheses. X and x, 1 plus and 1 minus. So I hope that's okay for doing the difference of two perfect squares. Okay, let's go on. Now we're going to be looking at quadratic trinomials. So this is, again, what I mentioned when I first did these the dots problem, is you need two numbers that multiply to 10 and add up to 7. So 5 and 2, multiply to 10, 5 plus 2 is 7, so you got x plus 5, x plus 2, that's how you factor that guy. This one here, you need two numbers again to multiply to 30, add up to negative 11. So you got to think about products, you know, let's see, 3 times 10 is 30, but there's no 3 and 10 are never going to add or subtract to 11, so forget that. Let's see, what else you got multiply to 30? 5 times 6 is 30. All right, a nice thing is, a minus 5 and a minus 6 multiply to a positive 30. Negative 5 times negative 6 is 30, and negative 5 minus 6 is negative 11, so that's how you're going to factor that one. So again, you can pause the video and you can try this one on your own just to make sure you're good with it. You need two numbers that multiply to negative 54 and add up to 3. So you got to think about the factors of 54. So let's see, 18, 36, 54 looks good. No, I don't think we're going to use 18 and 3. How about 9 and 6 make 54? So let's try 9 and 6. So we got a 9, we got a 6. We got to think of the signs. Has to add up to positive 3. So that means the 9, which is the bigger number, has to be the positive one, because 9 minus 6 would be positive 3. If you did it the opposite way, like negative 9 plus 6, it's going to add up to negative 3. You don't want that. You want it to add up to positive 3. All right. Now, factoring by grouping. This is going to be a useful technique for us. These are already partially factored. They actually factored out the x plus 2, the common factor of x plus 2. So now, since they have common factors, pull out the common factor x plus 2, and the other factor is x minus 3. It's actually that simple. You're just basically putting the x and the minus 3 in its own parentheses to make the other factor. Now, why would we need to do this? Because when you have a problem like number 11 here, where you have 4 terms, you're going to do a group of these terms and these terms, like this binomial and this binomial, and you're going to find the GCF of just this first binomial, x to the third plus x squared. X is the GCF of x to the third. I'm sorry, actually it's x squared is the GCF of x to the third and x squared. Now, you're ignoring this stuff. Of these two terms, the one that has the smaller exponent is the x squared, so the GCF is going to be the x squared. Dividing that out, you're going to be x third divided by x squared is x, and x squared divided by x squared is 1. Now you're going to do the next, now that we're going to put a plus here, GCF of 3x and 3 is 3, and then dividing it out, you're going to get x plus 1. And just like we had over here, we can take these terms, x squared plus 3, that's going to be one factor, and x plus 1, that's like the GCF of this whole thing, that's going to be the other factor. All right, you could try this one on your own. Make sure you got it. Remember, first you do a grouping. You could try, you could pause the video, see if you can get it on your own, and you can watch what I'm going to do. Greatest common factor here is x squared. Dividing out x squared, you get x plus 2. Now we're going to bring that sign down, the minus. GCF of these two terms is going to be 3. Negative 3x divided by negative 3 is x. Negative 6 divided by negative 3 is positive 2. One interesting thing is, especially if there's a negative here, and no matter what, actually, it's always going to be true. Whatever is in this set of parentheses is going to be in this set of parentheses, so it makes it actually easier to factor. Now you group these two together, x squared minus 3 and x plus 2. By the way, you might want to look to see if you could factor this further, but you can't. So this is going to be your final factorization right here, x squared minus 3 and x plus 2. Okay, let's go take a look at the next sheet. Okay, so here we're going to see, we're going to have trinomials with a leading coefficient here, a number that's in front that's not 1. If we took a look at the quadratic trinomials we had over here, there was the number in front was always a 1, even though it wasn't there. It was technically a 1. But here we have a 2. So I'm going to show you a technique that you could use. Again, it's like a factoring by grouping thing. But first, you've got to multiply the 2 and the 12 to get you 24. So First thing you do, multiply the 2 and the 12, you get 24. Now you're going to be looking for two numbers that multiply to 24. All right, and then add up to 11. So let's think about that. 2 and 12 can't add up to 11. 6 and 4 add up to 10, not 11. 8 and 3 multiply to 24. So here's what you're going to do. We are going to rewrite this. Leave the first term alone. Leave some space. Leave the last term alone. We said we're going to be using an 8 and a 3. 8 and 3 add up to 11, multiply to 24. Instead of writing the 11x here, we're going to rewrite this as plus 8x plus 3x. That's essentially 11x right there. We just decided to take 11, and instead of writing it as 11, we wrote it as 8 plus 3, which is also 11, right? So the idea here is that if we break this down the way I've done it, you can now group and easily factor. Let's see how. Let's take a look at the GCF of these terms. GCF is going to be 2x, okay? Then we're going to divide out that 2x. You're going to get x plus 4. And then we're going to bring down a plus here. Greatest common factor here is 3. And you're going to get an x plus 4 here as well. Just like we did on the previous page, these are like the common factors. So you're going to get 2x plus 3. Group those together. And x plus 4 here, and you're done. So you could basically try the same thing for the next two problems. Now, you try them, and I'm going to go over them, so this way you can check your work. We're going to multiply that first number and last number, get negative 15. Now we're going to find two numbers that multiply to negative 15 but add up to 14. So that's what's different here. We're not looking for two numbers that multiply to negative 5. We're going to look for two numbers that multiply to this number, negative 15, which we got by multiplying the 3 and the negative 5. Now, you're going to rewrite this. The first term doesn't change, and the last term doesn't change. You got to find the two terms that multiply to negative 15. So I'm thinking 15 and 1, right? What you're going to need, though, is a positive 15x and a negative 1x. 15x minus 1x is 14x. And 15 times negative 1 is negative 15. Oh, and by the way, if you put the negative 1x first and the 15x after it, that's going to work. That's going to be fine. What you can't do is you can't change the signs. I can't make this negative 15x plus 1x because then it's not going to add up to 14. But I can put these in any order as long as the 1 gets the negative. So I could have put that first if I wanted to. Now we're going to do the next thing. We're going to group these things. Greatest common factor here is 3x. Dividing that out, you get x plus 5. Bring down whatever sign is here. Greatest common factor here is just 1. Only 1 goes into this stuff. Now, if you divide by negative 1, you're going to get this again. Negative 1x divided by negative 1 is x. Negative 5 divided by negative 1 is positive 5. So notice, even if there was a negative here, it's still going to turn into whatever is there. So actually, a shortcut trick is, if you've done this correctly, whatever is here has to go there. Now you can get the 3x minus 1 as one factor and the x plus 5 as the other factor, all right? All right, again, you can try this last problem if you like. I'm going to do it, but you can pause the video, try it, multiply those numbers, you get 40. You got to find, I'm going to rewrite this 5x squared. I'll put a positive 8 out here. We're going to need the two terms in there. So we got to find two numbers that multiply to 40 and add up to negative 41. Well, what about negative 40x and minus 1x? All right, so negative 40, let's see if that works. Yeah, negative times a negative is a positive. Negative 40 times negative 1 is 40. And negative 40 minus 1 is negative 41. Now we could do our grouping here. Find the greatest common factor, which is going to be 5x. And then you get x minus 8. Bring down that negative 1. The GCF is just 1. And then you know that whatever is here is going to be these two things have to be the same. Why? Negative 1x divided by negative 1 is positive x, just like here. Positive 8 divided by negative 1, positive divided by a negative is a negative, so you're going to get negative 8 there. Put these together, 5x minus 1 and x minus 8. You've just factored that. All right, now, factoring completely. What factoring completely is, it's always the same thing. I mean, the problems can look very varied, but the same thing is always do GCF factoring first. That's the main thing. So let's take a look at this. Is there a GCF here? There is. 4. 4 goes into 36 9 times. 4 goes into 4x squared. If you divide it, you get x squared left. Now we're not done. We finished the GCF factoring, but now we see we have a dots problem, a difference of two squares. We can factor that. That's going to become, we'll bring down the 4. We get 3 plus x and 3 minus x. So when you're doing factoring completely, you do that GCF factoring, and then you continue to factor the second time. Let's try this one. Now this one looks like those problems, but it's not. Why? Because you can pull out a GCF here. The GCF here is 2. Always do that first. Divide out the 2, you get x squared plus 6x plus 5. Now this is just a regular type of quadratic trinomial factoring, finding two numbers that multiply to 5 and add up to 6. Bring down the 2. X and x. Numbers that multiply to 5 and add up to 6 is positive 5 and positive 1. There's a GCF out here. We did the GCF factoring first. Okay. Let's take a look what we got next. More factoring completely. Let's see how to do this one. Let's find the GCF. GCF looks like 3 xyz. So let's pull that 3 xyz out. Dividing everything by 3 xyz, we're going to get x squared, y squared, z squared, plus, this is going to be 2xy, and this is going to be a minus 1, okay? So I don't think you're going to be doing any more additional factoring on this. It's because there are z's here, it's not going to work, okay? So that's just a GCF kind of problem. But the next one looks like, let's see what we can do there. X to the 4th is a perfect square. 9 is a perfect square. 16 is a perfect square. So what you're going to wind up getting, I'm just making a bracket there so I'll rewrite this here so we have more space. You're going to get a 3 and a 3 plus and minus a 4x squared. And it doesn't look like you're going to be able to factor that any further. Okay, this problem pretty easy. Just do the quadratic trinomial kind of factoring. I'm going to skip that one. This one is just like, we'll go back a page. These problems here, we have a leading coefficient. So, you got to multiply those things first, but I'm not going to do that one. You can do it on your own for practice. See if there's any more good factoring here for us to practice. Yeah, here's another example where you have to factor by grouping. You're going to group here, you're going to group here, find the GCF. This case, it's w squared and w minus 3. Bring down the plus. Greatest common factor is 3, w minus 3. You get w squared plus 3, w minus 3. It looks like we've done before. And these are the problems. This looks like a GCF type problem to me. Let's see what we got. Actually, it's actually dots. See if you could figure out what it would be. The square root of this is 2xy squared. It's going to go on both, 2xy squared. Square root of that is 5x squared z to the 3rd. So we're going to get a plus and a minus. 5x squared z cubed. I got it here too, a minus 5x squared z cubed. All right? And I think basically this is, again, more factoring by grouping. So please just try it out yourself. I'm sure, let's make sure you can see this. I'm sure if you try this, you got a group here. I think you'll be fine. I hope that you understand the factoring. It's really, really important.